topics and the homeworks and the workshops, so everything's in here. So you should follow your syllabus. And let's take a look at the syllabus at the same time. So I'm on page 4. It'll come up in a moment, Carrie. So we covered all the first section of the course already. So that was all the component stuff, the resultants, statics. We're going to do one more pulley problem today after we go over this. And just to highlight also, let's look at the homeworks. All this is that first section of the course. Okay? So the first section of the course includes all these topics and homeworks. And I updated homework number 4 now. The solutions up here is homework number 4, and that's what's due on Tuesday. So all this is here. If we look at the workshops, for the first section of the course, it only includes the first 2. First section of the course only includes the first 2, and we did that already. And you'll see that the solutions for the workshops are up here. I didn't put the 3D one because it's just the sketch, but I put the dot product one. And then I had said I was going to do some review sheets. So the review sheets up here are the component rules, like how to represent a vector, what the 3 checks are, why do we use cosine, what do you include in a free body diagram, and then what are the rules in terms of units. Everybody see where I am? I'm under review sheets. And then I did a summary sheet for both components and resultants, and the different types of forces that we talked about, motion and concurrent forces and tension and normal, etc. So far what you see here for the first section of the course are the 4 homeworks and the solutions, the workshop solution, these reviews, and then there was a class question that we did in the solutions up here, and then there are 2 quizzes that we had so far in the solutions up here. And then all the videos, the 2D and 3D that you hopefully you watched before school started, and then Ben arranged the videos on, what did you call it? Playlist?
It's a playlist on YouTube.
It's a playlist, so it's all linked on here. So when you click on class videos, it shows all the videos that we've done. All right, so everything is posted for section 1. So we talked about when the exam would be, and I said I would talk about it one more time. So the last homework is due on the 14th, which is Tuesday. So we can have the exam a week after, or if you prefer, I can have the exam 2 days after the homework's due. Okay, so who would like the exam on the 16th? Put your hands up, high. Okay, Arturo, you want to come and sit at a table so you have a place to write? Okay, and who wants it on the 21st? Okay, it's on the 21st. Okay, we're going to do another pulley problem. So get out the pulley sheet. And we're going to do number 4. Okay, you can start. Oh, maybe you did already.
I did.
Okay.
Do you want to ask about board versus projectors?
Oh, yeah. Let's do this first, and then I'll ask. Okay. We looked at one already, so I want to go over that one first. So what we're determining here is a relationship between P and W. I heard recently, and maybe this has always been going on, but that Marcus in physics doesn't give any numbers in the problems, it's just all variables. So I guess this is kind of a Marcus type problem, there are no numbers. Okay, so we see that the weight is here, and we see the pull, the P is here, okay? So we already know that when you're pulling on a rope, this load, this tension in the rope is also going to be that same value. So P is here. This is the same cable or the same rope that wraps around the pulley. So this still has a value of P. And this wraps around this pulley too, so this has a value of P. So this one continuous cable has a tension of P in it. Good? Okay, then I looked at this pulley right here. And it has a P going down and a P going down, and let's call this T going up. Well, because I do sum of the forces in the Y, T minus these two P's make T equal to 2P. So now I have 2P here. I'm going around this, so this is 2P, same cable, 2P, and it comes down here, and now I have another pulley that I'm going to draw a free body diagram for. I have P going up, and I have 2P coming up, and here's my weight, so the weight is equal to 4P. Okay, so now I want you to do number 4, and you can work with the person next to you. And in this case, take a look. You could either start from P or W, wherever you want to start. In this case, I would, because, look over here, since there's some, actually you can start from either place. Okay, so find the relationship between P and W.
Boom! You just got static.
W doesn't translate as either the two places. It just basically goes
And then stop there. And then
that one now.
that would be it. We would have 3 1/2 P and then have 3 1/2 P.
Because that's the other, that's 2 minutes.
So then now make this, so that with that, and that means we have 3 1.5 P up, and that means one and 1/2 P.
I have to look up here for a minute. I'm listening to people and I'm finding that maybe another way, I mean there's always a few ways to do this. You might say, okay, well, this is one cable, so let's forget about the P's and T's and just say, okay, this is one cable, so let's call that T1. And then follow through and then find another. So you could, if you want, you could give the cables a tension variable, if that's easier for you, and then equate the T's to P and the T's to W, and then get the P's and the W's together. Okay? So that might be another way that makes it easier for you.
Tim, what'd you get? 4. Or did you do all that?
Yeah, that's right.
Okay, I'm stuck on 3. Number 3. 3A. Okay, so we have P, and we have P here. We have P there. And we have P there. Wouldn't it be W is equal to 4P?
You don't know.
That's I think that's just the biggest flexibility of each fully one at a time. Because then
Look, remember we did this W is equal to 40 P, that's P. That W is a short P. So at this connection point, this W is
3P. And W? What are you playing at?
Oh,
9 halves.
This W, so where did all these come from? Where are your W's? Where are your W's?
Sure. Yeah, so you're talking, well, so you're saying,
So all your tables, your W's.
oh, right here.
So right now they're balanced, nothing's moving. If everything needs to be balanced, then nothing can move.
Yeah,
All these forces.
but it makes sense now. So that's what?
Equals. What did we do here? Yeah, exactly. This is always equals 0.
So if you finished it,
You get our 2 P's.
if you finished it and you got 9.5, W is equal to 9.5 P or 4.5 P, then you got it correct. And if you want to, while waiting for everybody else, you can start doing some of the others.
So wait, you're saying 9.5?
9 divided, I'm sorry, 9 halves. 9 over 2, sorry. Oh, maybe I said that.
All this has to equal 0.
So it's either W is equal to 4.5 P or W is equal to 9. Just say 4.5.
Come together here. It should be.
So let's look here. So.
The first step is
I would like you to say this was my.
all you're doing is you're trying to transfer your W's through to a point to transfer your P's through to where they all move together. And then you can basically just combine everything because it's all has to equal to 0. Or they're just equal to each other. This W from the bottom has to be equal to all these P's coming from the top. What's that? We did. We transferred it through to here. And that's holding a third of this weight. Because this is holding the other.
Did you say for 5 W is equal to 9?
Yeah, and then just do that. We'll solve for W and P. You're just trying to do a relationship. Yeah. Some of the forces equal 0.
Right.
That one's in the negative. Those are positive. Both sides equal each other. Yep, exactly.
I like that jacket, Brian. Where'd you get it? Patagonia?
Okay, you ready? So I'm going to do it 3 different ways. Okay, so everyone look up here. Okay, first, to me, the easiest pulley is this one, because it only has 3 things on it. If this is P going down, what do these two have to be? P over 2. Right? And you don't have to write you have to draw the free body diagram. For this one, you don't have to draw the free body diagram, and you don't have to do the equilibrium equations, because we know this now, okay? So if this is P2 and this is P2, and how did you know that these are, you just half the P? They have to be in equilibrium, but one could be, you know, a quarter of a P, and one could be 3/4 of a P. It's the same cable. It's the same cable. This is the same cable, so they have to be the same. So P2, what's this? P over 2. What's this?
P over 2.
P over 2. What's this? P over 2. So now what is this cable? Something else. It's not P over 2. How come, Gracie?
It's attached to something else.
Right, it's not a
the same
continuous cable, right? It might have been off the same spool, but they cut it, they tied it here, and they tied it here, so it could have the same tension, but it possibly could not. So if this is P2, P over 2, P over 2, P over 2, what's this going to be? 3 times P over 2. So if this is 3/2 P, what's this? 3/2 P. What's this? 3/2 P, and then what is the weight going to be? Because now I'm doing the free body diagram of this. The weight has to equal what? 3 times 3/2 P, which is 4.5 P. Oops. Okay. Let's try it a different way. Let's go the other way. We'll start from this side. If this is W, what are these cables? 1/3 of W. Why? So one answer I heard is that there are 3 cables going up, so it has to be W divided by 3, but that's not the correct answer. Why is each of these cables 1/3 of W? They're all the same cable. It has to be the same cable. The cable that's coming up here is the same as here, and it's the same as here. That means that they all have the same tension. So it's W over 3, W over 3, W over 3. Right? Just because there are 3 cables there, it doesn't mean that they're all equal. They just are equal because it's a continuous cable. If this is W over 3, what are these going to be? First, what are you observing about these 3 cables? They're all the same cable. So it's going to be what? Either one is going to be, all of them are going to be W over 9, W over 9. So we have W over 9, W over 9, W over 9. What's this going to be? W over 9. What's this going to be? W over 9. Right? So what's P going to be equal to?
2W.
2W over 9, which is P is equal to W over 4.5, which is the same that we got in the other one. So the important thing is to find which cable is actually the same, and then you know it has the same value. Good? Okay, so you just have to do the rest of them for homework. Yeah, those get turned in with the homework.
Yeah, that was